Okay, so how do we define a list in Maxima?
It's like the double brackets. It's like C.
The square brackets, right? So I can start with an empty list easily by simply doing X open square bracket, close square bracket, and that is going to give me an empty list. So nothing in there. Let's say if I want to put a bunch of elements in there, what should I do? I can have A, B, C, or 1, 2, 3, 4, etc. But I'm actually going to use a function in Maxima to create this list. So the first one is append. So append, push, pop, all of these functions are in Python as well. R doesn't have them. You have to install a separate package to get those functions. But then you can call Python from R. So append A to list X. Oops, it's probably backwards. What in the world? When in doubt. No. Let's do append 1 to X and see what happens. Doesn't, must be non-atomic. X and 1. Okay. Perhaps it would want a list with elements in. It should work. So let's see, append 1 to X. 1 as a list. Then you just have to specify it as a list. So when I append, you have to put square brackets or else it is giving an error. So you can't directly append a number, you've got to append within square brackets. Because it would have worked with the empty list also. The place where I was going wrong is I didn't put the brackets. So what did you notice when I added that 1?
There's now 1 at the end of the list.
It added 1 at the end of the list. So append is going to add an element to the end of a list. Now, could you add a list to a list? In other words, I want to have a list inside here. Would it be possible? I don't know. I don't use Maxima all the time. But if you have to use logic, how would you go about doing that? I want the 5th element to be a list. Let's say it is a list containing 2 numbers, 64 and 128. So the first square bracket is the requirement for the append function. When I first did it, I forgot and I got an error. Now, inside that square bracket, I am going to put another square bracket and do 64, 128. See what happens. I got 64, 128 as an element inside the list. Yes.
So if you wanted to do it where you like kept adding things, 'cause it took away the one when we appended X the second time. So would we have to like assign a brand new list?
It did take the X the second time because it's replacing whatever that was the last element. So if you want that, excuse me, the one, if you want that one back, you do 1, 64, 128. Append is just going to keep on adding to the existing list. So let's see. Append X. I'll just do, I can do a string. I'll do apple. It should let me. So you can see when I append to X, it replaces the very last element. Now that's a problem because if you want to grow the list, then this would be an issue. So how would you go about fixing this problem? You know, you want to keep on growing the list instead of replacing the very last one. Assign X. So let's assign append to X and see what happens. Now X right now is 1, 2, 3, apple. Let's try and append. This time it included the 64, 128 as list, and then apple. So within the function, X has a local scope in the sense it is a temporary assignment, and whatever assignment was made, the very next append that you applied replaces the last element. But if you want to keep on building the list, you have to make an assignment each and every time. And if you don't make the assignment, your list is not going to grow. Does that make sense? That's the append command. The next one, let's see. Just put a note here. Oops. Just say it requires recursive assignment to grow the list. The next one is push. We're about to push the list down the stairs. So push. Let's see. We'll try this. I'm going to do 1, 2, 3, 3 elements. I'm going to push that to X. X is what we have already, so we'll see if that works. Okay. So push 1, 2, 3 to X. Ended up getting 1, 2, 3 pushed to the very front of the list. So that entire list became an element of the list. Now, going to push A, B, 2 strings to X. What just happened?
It didn't replace 1, 2, 3.
It did not replace 1, 2, 3. So it automatically builds the list for you. So push does not require recursive assignment. Forgot to say. What did I say?
The first fragment.
Good. Are we clear with append push? The next one is pop. Any guess as to what pop would do? Play a pop song?
I mean,
What? Any guesses?
delete an element from the list.
Delete an element from the list. Okay.
I don't know.
So- Pop X. So it popped X out, and it gave me the first element that was in X, which is the list A, comma B.
Change that.
Now, what happened to X?
Nothing.
It literally popped, right? So that's list A, comma B is no longer in X, it completely came up. So the next time I apply pop, 1, 2, 3 will also come out. So the advantage of pop is going to pop the element and return a value. So if you want to pop an element and save it to something or a different variable, you can do so with pop.
You specify which element you want to pop out. Or is it always gonna be the first one?
That's what of course. Now you may ask, well, what do we do if I have to get a specific element? We have ways to do it, and I'll show you how. Let's say if I want to delete a specific element. I can simply say, I believe it is X followed by the character, the element of the list, or could be the other way around. Oops. So backwards. So delete apple. So it automatically got rid of apple for us. So did X change? That's a question. Did X change or did it not change? X did not change. Yes. So sure, deletion deletes a value, but it does not save the value to X. So you have to save. In other words, an assignment is required. Good. Let's see. I just use 1, 2, 3, 1, 2, 3. Let's go ahead and push -1, 7, 11 to X. I want to print 11 by accessing X. We know when we push, X automatically changes, so the object X has the number 11. Now I want to print 11. How would I do that? Do what Joe suggested. So Joe said, well, let's put the going to pop X And of course, I have to save it to something. So we'll call y. And y is going to have -1, 7, and 11. And how do we combine two strings? So we want to concat so that I can print, but do keep in mind concatenation can only do it with strings. So you can use the string command to cast a number as a string. So I'm going to convert the third element of y, which we popped from x, save it to y. Hopefully this works. Well, so let's insert a space. My number 11. Good. Now, Benton's approach without using pop. Any thoughts as to how we can print the number 11 without using pop? So you see the reason as to why this approach could become troublesome in certain cases. Because you'd be losing information. You've got to re-enter. So I've got to push the list that I took out back in. It'll automatically change X. We know push changes the object without the need for an assignment. Now print. Concat. My number. You've got to convert it to a string. Don't forget. So string, but how would I go about doing this? Ben, he used fancy words, list, sublist, sublist.
I was thinking like 3 or something like that.
X bracket 1 bracket 3. Okay. So X, the first element, 1. So the first element I know is a list. So when I do X1, that entire object is now a list. And the third element in there is my number 11, so 3. There's nothing wrong with the first approach, but that requires extra care because you're changing objects, and if you don't keep track of the changes, you're not going to get the correct answer. This, on the other hand, is being very cautious. So we always access elements using square brackets when it comes to lists. The next is association. Association typically happens in a key value pair type data. So we need to have a key, we need to have a value. In Python, it's called a dictionary. In R, it's just an S3 or S4 object. So just going to do associate Apple, and I need a key value pair. So I'm going to define Apple equals 5, orange equals 11. So what did it do? It actually searched for the key apple in that list and returned the corresponding value to the key apple. Does that make sense? Okay. Key value path in Maxima over here requires an equal sign. If you put a colon, it is not going to recognize as a key value path. Good. And associate is not going to work. Are we clear?
So what precisely is associate doing, or associate doing?
Come again.
What precisely is associate doing?
So if you have a list of key value paths, this is the key, that's the value. And if you pass, one of the keys, it will return the corresponding value. So I'm searching for the key apple, and apple has the value 5, so it returns 5. Now, if I change, and for instance, I did associate cut, or even, how about this? Still using apple. What do we expect to get? I got nothing. Why?
Because it's apple.
Looking for a string.
This is a string. So an associate is looking for apple. It is not looking for a variable apple. It is looking for a string apple. So there isn't one, so it returns false. Good.
Can you explain one more time why we need the equal sign instead of the colon?
Because it is a key value path. So we're using a key and a value, we're not making the sign. So I'll get into key value paths. We sort of did it last time when I created the list. I gave a name Rob and had a number. So by all means, that's sort of a key value definition. So we'll do that today also with R. So in Maxima, key value paths are defined as apple with an equal sign. This is great and all, but sometimes we want to create a list easily. So there is a CreateList function. It's create_list. Give me a function.
Like a maximum function or like a direct?
Some function, simple function.
X equals, y equals the square root of x.
X.
Y equals the square root of x.
Square root of x. Fine, I'm just going to do x raised a plus 4. So x is my expression, a is the variable that I'm going to change. In Python, that has a very specific name. It's called an iterator. Of course, we have iterators here in Maxima. We have it in MATLAB. We have it in R. But they come into play when we do loops. But by definition here, this function, in this function, a is sort of an iterator. What do I mean by that? So when I have x raised a plus 4 and put a, that a can be varied. So Chris here wanted square root of x. So I'm going to put 1/2. I like a square. So I'm going to put 2. Anything else? A. Just for fun, let's put -1. Good.
Yo.
I get a whole lot of stuff. Can you tell me what I didn't expect this happen? What went wrong?
I think it's accessing the list X.
We didn't kill X, we used X already. So
Oh, shit, you're
we have to kill X
right.
first,
Whatever Apple.
or let's just use the difference variable. Oh, we can't use Y either. Let's use U. No. Not
Kill
that.
you?
U.
That's not very good. Well,
So what did it do? So it went through every single value of A, excuse me, in this list and plugged it in there. So we have to define what A is in order to get the values. So for instance, you have U raise A and put B up there, it's not going to work. Yes, because the values are defined for B and not A. So that is one way of creating a list. Later on, I believe there's something called make list. We'll get to that in a bit. Sometimes one may want to, create a bunch of expressions, in math, when we do derivations and stuff, we like to combine terms, expand terms, etc., etc. And Maxima is a computer algebra system, so it should be able to combine, expand, integrate, differentiate, and so forth. So what I'm going to do is I'm going to use an apply function and put plus. And go back and save my list that I've created, let's say to the variable s. So apply plus sign, saved it to s. Don't forget to run it again, so control enter. Because the first time I ran it, I didn't save the list to S. Good so far. What did it do? What?
It added the list together.
It added all the elements together for you. Right. So, at the end of the semester, you would start wondering, man, why did they make me take out 1, 2, and 3? Because it pretty much is going to do everything for you, even differential equations. Now, there is an apply function in R, but it is not going to work this way, obviously, because it's not a computer algebra system. Could I change this to a different operator? Let's see, what can we think of? Let's do something funny. Variety is the spice of life. How?
Oh. Yeah.
Good. Didn't work.
Oh. Yeah, makes sense. Maybe it has to be
Maybe it's making sure it doesn't know the power tower.
Probably. Let's do minus. That works. It's applying minus to every. I see why. It couldn't apply power to the first one. It can only apply to the second and so forth. That's why, as you can see, when I apply that negative sign, it is applying to the first element also. And if I did the power, Maxima cannot put a power here. That wouldn't make any sense. Correct. That's why we got that.
I think with a -8 instead of
-16.
-16.
Yeah.
So let's say 4 minus 4 minus 4 minus 4. That's -8.
Wait, subtracting everything from the first.
So it's let's say,
That's weird.
but to switch the order. But the way it works is it's applying negative in what order?
It's subtracting everything from the first one.
So it's starting with u raised 8, the highest power. Apply negative, so minus u raised 8 minus 4. Minus u squared minus 4, that's minus 8.
Doesn't even subtract the square root of u, you did.
It didn't subtract the square root of u.
I think it's subtracting everything from the first unit.
Yeah.
It's subtract, the first term's positive, everything else is negative. It's subtracting everything from the first one.
It should apply to every single term. So first term, 1 minus 5 minus 11 minus 8. That should sort of make sense. But why did it start with u raised 8 plus 4? It should have started with square root of u plus 4. But why did it go to u raised 8 plus 4?
That's a standard
It's
distribution.
8, then 2, then 1/2, then -1, then 0.
8, then 2, then 1/2, then -1. Say the order of the powers. There is a way to change it from last time. How do we change it so that it goes from u raised -1, u raised half, u squared, u raised 8?
It's like polygon.
What? Poly what?
No, it's, I literally remember this.
Power disk, very good.
Power.
Cons, I mean, what does it stand for? I believe it stands for construct. I could be wrong. A, and let's say I have B plus E. Oops. B plus E. What did it do? It just added A to B and E. Now, if I simply have cons A comma B, that's a problem because it's looking for some sort of an expression or an operator. So suppose I have A and some function f of x. So A, some function f of x. And what did it do? Why did it do that? It didn't kill x. So let me change that to v. What did cons do? It just took this A, added it to the function, created a new function. Again, you may say, well, why should I know these things? Well, when you derive stuff, sometimes in math, you're deriving, you have a single variable function and you do some sort of a derivation, you're defining a variable, a function, two variables, right? If you're expecting a computer to do all the derivations for you, Maxima, Maple, etc., you've got to know how the program's going to combine stuff. Yes? So if I just want to insert a variable, I can do it as f of a comma b. This will be a new expression. One interesting aspect about cons, I think q comma minus q. That gives me 0. Yes? I think it's in flag. So in flag is another flag. Currently it's set to false. I'm going to turn it on, convert it to true. go back to cons. What did it do?
Whoa. Multiply them?
It multiplied them instead of added them. So the flag is going to define how it's going to interpret the function. So I had cons, in flag currently is true. We do f of v and see what happens. Even though the in flag is true, it didn't make a change in an operation of this sort. The only place where it matters is with addition. Good.